I'd like to say that we will record this, so we'd like to get your permissions as well. We got the permission of Lara. Well, on behalf of Turkish National Committee on Illumination, it's a pleasure for us to welcome you. And the reason why we're together gathering today is, of course, for the sake of International Day of Light, which we celebrate actually in the second and the third weeks of May. Surely it is always the 16th of May, but we are, as being the committee, enlarging these activities, online activities, face-to-face activities. And today we are one of these very important webinars. We have a very special guest, Laura Bellia. But before giving the floor to her, I would kindly ask the president of our committee, Professor Dr. Sermin Onaygil, to welcome you.
Yeah, thank you very much, Banu. It was a very pleasure for me and to say something to welcome for Laura. Yes, Banu mentioned already as Turkish National Committee on Illumination, we call this ATMK, and we organize events every year within the framework of Day of Light. One of these is our international webinar where we have the opportunity to listen to valuable expert guests, of course. We can say that this event has now become a tradition. We can say that because every year we have continue. And this year we are together, as you see that, with our dear guest, Professor Laura Bellia, who has made very important contributions in the field of integrated lighting systems within the building systems. And I'm sure that her talk will be eye-opening for all our participants. Also for me, I'm exciting to listen to her. On the other hand, Laura is both my working and personal friend. And we are also working together on the CIE governing board this term. We were also together in Genoa last weekend due to our meeting. We have seen each other. Of course, it was a very good time for us. We enjoy it. You can imagine that we came home late last night and we appreciated the value of the time she has dedicated to us. Despite her busy program, I have known her program is very busy, and we thank her very much. On behalf of our National Committee, I would like to thank for all the participants to their attendance for this workshop and wish a productive and enjoyable and friendly atmosphere as a webinar. Now I give the floor back to Banu. Microphone is for you, Banu. Thank you very much. It's
Thank
very
you.
good atmosphere. Thank you.
And before giving the floor to dear Laura Bellia, I can read a few remarks from our very valuable curriculum vitae. And as we shared with all of you, she's a full professor of lighting and building physics at the Department of Industrial Engineering of the University of Naples Federico in Italy. And her research interests include lighting, daylighting, smart lighting systems, and automatic controls, integrative lighting, as Sermin Hocam indicated. She is the author and co-author of more than 120 papers about these topics, which is an incredible number, that was published in international and national journals. She led national research programs about indoor lighting quality and daylight harvesting and participants in international research projects during which the same topics. Since 2013, she has been a member of the board of directors of Lux Europa, Currently, she acts as members of the CIA Governing Board for the term 2023 to 2027, and she is also, meanwhile, the secretary of the CIA Division 6. Actually, I am Turkish representative there, and we work there. That represents photochemistry and photobiology. She is the president of the Italian Lighting Association for the term 2027 to 2025 to 2027, and scientific manager of the National Committee CIA Italy. She is member of CIA TC 357, TC 360 and TC 361. She is co-chair of the again another working group belonging to CIA. And you see lots of administrative works and lots of productive portfolio, which I admire personally. So thank you again once more to be with us today, for inviting uh, for accepting our invitation, and the floor is yours.
Oh, thank you so much, Banu. Thank you so much, Sermin. I'm very, very glad. I'm honored to be here and also to speak about indoor lighting, considering all the aspects. And I want to thank you all, to thank the National Committee CIE of Turkey. And I have to say that I feel a feeling of friendness with all of you, just because I have worked or know your work. I sincerely respect your work and admire your efforts in the CIE community and in the lighting community in general. So I'm very happy for this. Just for this, I would like to share my screen just to start the presentation. This is the screen. Okay, and I would like to start with the presentation. Okay.
Everything is okay now. Yes.
Everything is okay. Thank you so much. So I would like also, okay, use the laser.
Yeah, it's using.
Thank you. So I have put a little change in my title. So the title, the final title is quite the same, but indoor lighting quality, considering all the aspects that generally are considered performance, wellness, and also energy efficiency. So let's start. Let's start from one more generic and multidisciplinary concept, the concept of IEQ, that means indoor environmental quality. And indoor environmental quality involves both thermal hygrometric, thermohygrometric comfort, and also air quality, and also visual and acoustics conditions. And also today we consider ergonomic and also psychological factors. So indoor environmental quality is a multidisciplinary field, and in some way for indoor environmental quality we define how healthy, comfortable, and also efficient an indoor space is. So let's pass to the lighting quality, so the visual aspect, and to the lighting quality definition. So I would say one thing, when you have a doubt about some term for lighting, please go to the CIE EILV, because you can find the right definition. So I would like to start from the lighting quality definition from the CIE, and as you can see, it is the totality of lighting characteristics that fulfills the user needs and also the user expectation or other applicable requirements. So I would like to show this famous picture from Jennifer Witch, our president, that shows how lighting quality includes individual well-being, architecture, and economics. So we have all included into this concept of lighting quality. But if we wanted to consider the indoor lighting conditions in general, we must take into account for three main group of aspects. So here you can see the human being. Without we humans, we couldn't speak about lighting and visual comfort and so on. So we have to know how we work as for the visual, and we'll see also non-visual aspects and our characteristics. Then we have the so-called primary sources of light. So both the electric light sources like lamps and luminaires and their technical characteristics, but also daylight. Daylight, as you know, is very important, and also the light that serves importance. And as you know, and as we will see later, daylight is variable during time. Then we have the environment where lighting is distributed. So it's very important to know, for example, the optical characteristics of the materials and how also the geometry, the architecture, and all of the characteristics that define all these aspects. But how to consider all these data? It's a big amount of data. So in order to design properly, we have standards, because we have in some way to comply the international standards. In order to process all this data, we can use calculation tools, and also to verify if the lighting conditions are proper or not, or are those that we expect. The use of measuring instruments is also very important. So we have this slide that means that on the one side we have the lighting environment, and the lighting environment is done by both the sources, both electric light, daylight. The spectral distribution is very important, but also how we control the light, both electric light and also daylight, for example, shading systems, or even the design of the envelope and the characteristics of the envelope. So we have on the one side the sources, the systems to control these sources, and the physical interaction with light and the environment, so the optical and the geometrical characteristics of the environment. And this determines luminance distribution, contrasts, illuminance on the task areas, uniformities. We have to check for glare. We have to consider the 3D models, so the modeling of the light, the spatial distribution of it. We have to avoid flicker and so on. And all of these things that we have to define and control produce, on the one side, visual effects, i.e. visual perception, and on the other, non-visual and also emotional effects. In these non-visual and emotional effects, there are included not only the circadian and the attention effects that now we are starting to quantify, but also other aspects that deserve attention, and I'm sure that in the future will be more included in the design, that are the aesthetic appreciation, the seasonal affective effects, the preferences by the users, and also the mood. So all of these is responsible for human well-being, but we must not forget that energy is very important. All these things are energy consuming, so we have to reduce energy consumption while increasing energy efficiency. So we have all of these together. So if we consider visual and non-visual effects together, we can speak about integrative lighting. So first of all, what is integrative light? Go to EILV and let's read what is integrating light. It's the lighting that integrates visual and non-visual effects and produces physiological and psychological benefits upon humans. Perhaps the term integrative light is not so common for you, but for sure I'm aware that human-centric light is used, and it is the same. It is used with a similar meaning. So we have to balance both visual, including visual effects, including performance, comfort, and the perception of space and objects, human recognition of the environment, and so on, with non-visual effects that are alertness and attention, circadian rhythms, and in general, more in general, well-being and also health. So, in other words, we have to balance, in a term that I say sustainable lighting, both the integrative lighting requirements, that includes, as we see, visual and non-visual, with other requirements that in some way are for the benefits of our planet, so energy savings, environmental impact, resource conservation, sustainability, and so on. So we have to balance all of these aspects. I would like to show that I would like to use this term good lighting. Why? Because
Olha, uma senhorinha.
please. We have good lighting. Why I use this term good lighting? Because this was introduced in a recent standard, the ISO CIE 8995 Part 1 for lighting for workplaces, and it gives a recommendation for good lighting in order to fulfill the needs of integrative lighting, because in these standards, integrative lighting is included, even if in not a mandatory aspect. So what we mean for good lighting or lighting of good quality? It means to use quality for source and luminaires. So it means appropriate choice for color temperature, very high color rendering, proper optical systems in order to distribute lighting in the space in the best way, according to the different activities that are performed in these environments, reliability, and obviously low impact on the environment. But all these qualities are useless if you don't have a good quality for lighting design. In other words, you can have wonderful luminaires, lighting systems, and so on, but if they are put in an environment without a good lighting design, it's good results will not achieved. So we have to achieve luminance distribution suitable for visual comfort and for carrying out the different activities in the environments that are required. So create lighting scenarios that adapt to different conditions, and also, but together, take into account for the non-visual effects of lighting. Last but not least, we have the problem of energy savings. And I say to you that to achieve energy savings, we have obviously to use sources of high luminous efficiency, high ratio lumen watt, but above all, we can save a lot of energy by using control system in order to manage the lighting system in the best way and use, when available, daylight, but also, as we will see later, switching off the light when the environment are empty. So, in order to obtain good lighting, we can we must have dynamic light. In other words, light that varies during time. Obviously, daylight is variable during time, but also electric light must should have these characteristics for the benefits of humans and environment. So why a dynamic lighting approach? in order to adapt to the natural light variability, in order to support the different activities that are performed in the environment during time, in order to entrain properly the circadian rhythms, to improve well-being and health, and also to obtain lighting for people that can have a visual impairment on other. We can modify the lighting system for everyone, and also to obtain energy efficiency and save energy. So, according to this, I would like to show you some environments where, on the contrary, we have constant lighting for 24 hours a day. What does it mean? That if you stay, for example, in this supermarket at 9 a.m. or at 6 p.m., it's the same. So people who are working there will not recognize any difference during time. And this is not at all good for their benefits, for their health. This is a gym and also office. These are very, very bad environments. And let's consider that we live in indoor environments generally about 80% of our life, of our time. So it's really a big amount of time, and indoor lighting deserve a very, very accurate attention. So here is a list of disorders that can be caused by improper light, starting from a simple eye irritation or dry eyes or frequent blinking, but also headaches, sensitivities to light, for example, glare, and also the disruption of circadian rhythms that produces sleep disturbances. But starting from these sleep disturbances, we can have also other problems, for example, reduction of the immunitary system and a series of other impairments. So it's really, really important to have a good light. So how to approach the design phase? We have the light that is dynamic at our disposal. On the one side, we have our needs, both visual and non-visual, i.e. integrative. And on the other, we have the light sources, both electric light and daylight. Last but not least, the energy issues. So as for the needs, we have to refer to something. Let's consider this. And we have several standards, international standards for indoor lighting. As you can see from the titles, they are lighting for workplaces. There are very small, very few standards about residential lighting, but we can find something similar also for residential. And you can see that some standards are European standards, are international ISO. But if you can see these two, they are very similar to each other. And in the future, I hope that there will be an EN ISO CIE standard, because they are very, very close to each other, and it's useless to have both of them. Then we have also some standards or recommendation for integrative lighting, the ISO CIE 2022 integrative lighting, and also a position statement on integrative lighting from CIE, recommending proper light at the proper time. And this standard is free for download from the CIE website. And also the institution of the metric for calculate circadian quantities, and this is the CIE system for metrology of optical radiation for IPRGC. We'll speak later about this, influence the responses to light. So we have a lot of standards and recommendation for the needs. And for the light sources, we have that for the electric light, we have the materials provided by the manufacturers and their characteristics, their technical sheets, and so on. And for daylight, just to quantify daylight, we have a standard as well. It's European standard, 17036, daylight in buildings. So we have several standards. Just to complete this framework, we have also the standards for energy. You can see here a big list of standards, but don't be worried, they are similar to each other because ISO CIE and European are close to each other, and there are several standards to evaluate the energy needs for lighting in buildings, and also using daylight. So some of them are for calculate the impact of daylight for the energy performance on lighting. Other are more complete and as we will see later, they introduce the LENI, light energy numeric indicator, just to quantify the energy performance of lighting systems. So how to manage all of these? We have to manage this, we have software at our disposal because it is impossible to perform a calculation of this type by hand. So what software to use? We have several software at our disposal and they differ for the simulation methods. For example, there are very simple software just to quantify the number of luminaires to obtain its very simple software. Other based on the radiosity method. For example, all the interreflection are calculated basing on the fact that all surfaces are perfectly diffusing, or inverse ray tracing method, or hybrid methods. So even if you use one software, you have to know what method is applied, but this is only a part. Also, the modeling approach is different because some software are based on photometric quantities. So they provide, for example, luminous flux from luminaires and then calculate directly luminance, and so on. And also reflectance factors. Reflectance are given without considering their spectral characteristics. Other software is based on 3-channel RGB models. So in some way, they use something which has something to do with the colors, with 3 channels. And today, we have also software based on spectral analysis from 6 to 24 channels. But today, there's also a software with 81 channels. And so it is possible to consider spectral characteristics of the radiation from luminaires and to calculate a lot of quantities, included the non-visual effects and the non-visual metrics. So it's not finished for software, because as for daylight, we have also software that can have a static approach or dynamic approach. What is the difference? For static approach, we can calculate daylight conditions when we choose 1 hour of the day, 1 day of the year, and so we simulate the condition, and we have also to select the type of sky, for example, if clear sky or overcast sky or intermediate sky, or another type that we can measure. And in this case, we can also have a mixed approach with the daylight and electric light, considering also the light from luminaires, but we obtain the values in the environment, and we can appreciate through this simulation what is happening inside the environment. Is the environment is good to be seen, if some conditions are comfortable or not. On the other side, we have a dynamic approach, the so-called climate-based daylight modeling method. And in this case, you can evaluate during a period of time, for example, 1 year, how many for how many percentage of time, for example, daylight is sufficient for complying the requirements on the task area, or and so this is called daylight autonomy. But you can also evaluate some synthetic metrics, for example, the continuous daylight autonomy or the spatial daylight autonomy, or annual sunlight exposure. So for how much time and in what portion of space we have, for example, direct sunlight. So this is very good, this dynamic approach, to understand if and what control system to integrate the light and electric light is more applicable. So this is a very good analysis. So if you ask me, what is better, a static approach or dynamic approach? They are both necessary to better understand how things are working. So all of these aspects, as I told you before, produce visual perception. How to consider these visual aspects, how to quantify them. We have at our disposal the two main standards are the European one, 12464 part 1, and the second one is the recent ISO CIE 8995 part 1. They are similar, lighting of workplaces, indoor spaces. And in these cases, it is said that the lighting requirements should satisfy three main human needs. The first one is the visual performance, and then the visual comfort, and also safety. So here is a list of parameters that we have to consider, obviously using software, because software is necessary. We couldn't avoid to use software. And as you can see from the previous slides, the use of and the choice of software is really important, and the designer should use the software with awareness. Let's consider that software makes calculation, but it is the designer that has to take decisions. So we have, this is the list, you know probably all of them, luminance distribution, the luminance on task areas and also on the different surfaces, uniformity, glare. Glare deserves a specific attention because we have glare from electric light, the UGR, and the glare from daylight, for example, daylight glare probability. There's not a glare index for both together, so it's very difficult to approach glare, but we have some indication. Then we have also the light directionality, so the modeling. So this is really important to obtain a 3D, to enhance the three-dimensionality of the space. And then also color rendering, color appearance of sources. For example, it is better warm light or cool light, it depends. And it is possible to change it during the day, it depends. And so you have to make all the choices, flicker. And then we have also, of course, the variability of light, the non-visual effects, and the energy consumption. And this last is very, very important. We have not so much time to for this, but operation and maintenance are very, very important. So this is an example of the parameters that are required for the different activities in these standards, and also in the ISO-CS standards are reported for each activity, the required luminance values, but also uniformity, color rendering, glare, and so on. For example, cylindrical illuminance, this one, for visual communication, and several other parameters. So for these visual aspects, we have a complete amount of parameters and the values that should be achieved. What is more difficult is the non-visual aspect. I try to make a very simple explanation of this. We have these non-visual responses, and they are very different from visual responses. Why? Because where visual responses are immediate or quite immediate, they depend only on the adaptation of the visual system that requires not so much time. For non-visual responses, we know that they depend on the spectral distribution of the radiation at the cornea, the amount of light received, so the exposure to light, the time and the duration of this light, and also on the previous history of light exposure. So they are much more complex. And these non-visual effects are due by some photoreceptors called intrinsically photosensitive retinal ganglion cells. So Here are the conventional photoreceptor, rods and cones. But in the part of retinal ganglion cells, we have these intrinsically photosensitive, and they contains an opsin called melanopsin, and they receive the luminous signal and send this signal to the brain, but not to the visual cortex of the brain that is responsible for our visual for the visual aspects, but to another part of the brain, the suprachiasmatic nucleus, and other parts near to them, and they produce effects like, for example, production or suppression of different hormones, like, for example, melatonin and cortisol, and for this reason, they are responsible for the wake-sleep cycles. What is the problem? The problem, besides the other one, are that for visual aspects, we have this curve of sensitivity. For non-visual aspects, the melatonin one, we have this other curve. You can download the Excel files of these curves from the CIE website as well. And now I try in a few minutes to show you how to quantify the circadian effects according to CIE. So let's consider the natural light, daylight, D65 spectrum, that is the standard illuminant D65. This is, let's consider this is the spectral irradiance at the eye level, at the light, the radiation that we receive at the eye. This is the spectrum of daylight. And what we see is the area under the brown curve, this V. So the irradiance is 1.22 watt per square meter, but we see 250 lux, and this is proportional to this area in brown. But the circadian effect is mediated by the M melanopic curve, so is the area under this curve. Okay, it's different. So with 150 lux, we have an M. If we consider this area, it is 0.33 watt per square meter. And we can also consider the melanopic spectrum efficiency, which is the ratio between M and the illuminance, 250 lux. And we have this ratio expressed in milliwatt per lumen. It is 1.3, around 1.3. This is for daylight. This is the spectrum efficiency for this daylight. But if we change light source, let's consider an LED with, let's say, a correlated color temperature of 2700 Kelvin. We can see that the visible part, for example, is the same as for the daylight before, so it produces 250 lux. But the melanopic effect, it's, you can see, it's lower than before. This area is lower, you can see. I can show you, it was there, and now it is small. So the M is smaller, and the efficiency is also smaller. The M divided by illuminance is much lower. So the idea to introduce a new quantity to quantify the melanopic effect is, if we want to obtain the same stimulus M, this one, with the standard natural light, D65, what would be the corresponding photopic illuminance? In other words, we want this M, but with the daylight. As you can imagine, the light will be not the same as before, otherwise M is higher. So let's do this. So this illuminance produced by the illuminant D65 corresponds to a photopic illuminance called illuminance of D65, and this illuminance is called melanopic equivalent daylight illuminance. I know that this is not so clear now. I try to explain briefly. So we have the MELEDI, that is the luminance produced by the standard D65 that determines the same melanopic stimulus as the source we are considering. So let's consider the melanopic spectrum efficiency for the D65 and for the source that we were considering, the LED 2700 Kelvin. This is the ratio. For D65, it is much higher. But just because we want the same M, the melanopic should be the same for these two. I write again this with M and M. These are the same ratios, but here we have M and M because they are perfectly equal. We want the same melanopic effect. So, given that, we can divide this melanopic ratio by this one of the D65. So this ratio divided by this one, so it is upside down. So M and M are eliminated, and we have the ratio of the two vertical illuminance, photopic illuminance, D65, and the source that we are considering, in this case, the LED 2700 Kelvin. And now, from this ratio, we can obtain the illuminance obtained with the D65, this one is equal to this ratio multiplied by EV. So this ratio multiplied by the EV. Also, this one is called MELEDI, melanopic equivalent daylight illuminance. So this is really important because today some scientists and also some standards consequently are considering a quantity of melanopic equivalent daylight illuminance to be achieved during part of the day. So if we consider this ratio, okay, this one, this ratio is called MELDER, melanopic daylight efficacy ratio. I understand that all these terms are very tricky and cumbersome to be retained, but I know that our president Jennifer Witch will propose a report to simplify this terminology, which is very, very hard. So the MELDER is this ratio. And this ratio, what is important, even if you haven't followed perfectly all these passages, the important is that this ratio depends only on the spectrum, okay? So we can calculate the MELEDI considering this MELDER that depends only on the spectrum, and the illuminance from the source that we can calculate or measure. How to calculate or how to obtain this MELDER? This MELDER can be calculated. I go faster. The MELDER, in this case, for example, we obtain that the MELEDI for this spectrum of LED is 107 lux. It's lower than 250. So it is, as you can see, this is M and M, they are equal for the two spectra, but the visible part of the LED is higher than the D65 one. And for the reason, this is the MELEDI. So how to calculate the MELDER? It is better to say MELDER rather than MEDER because M can be confused with the M cone. So it is, here is a table, for example, produced by Germany. In Germany, we had, this is a German standard, and in this case, for different spectra, the MELDER are used. So I'm aware that the time is going very, very faster. So I want to synthesize all of this and say, okay, For these non-visual effects of light, we have to consider the melanopic equivalent light illuminance, but we have also to consider that we don't receive light only from the luminaire, but also from the surfaces, and the surface reflect light, and the surfaces modify the spectrum of light. So this is very, very difficult. So in this case, we can obtain this prescription. We have this prescription from the scientific world and also from the standards. So generally, we should receive at least 250 lux during daytime, let's say before noon. So we have to receive a lot of light during the morning. Then in the afternoon, it's not important what we receive, but the important thing is that before going to sleep, we shouldn't receive more than 10 lux. 10 lux, not photopic lux, but melanopic eddy lux. So this is good, and obviously during night we should stay in the complete darkness. So this is a good pattern to entrain the circadian rhythms. Obviously, if you ask me, but it is better to obtain, it is necessary to obtain 250 lux for all the time or for 1 hour, 2 hours. I have not the answer, but I believe that we as designer or teachers should design environment that accomplish these requirements, and then people move or do something, but we cannot control all the activities of people. But the important is that the environments are good for their health. So the things are very, very complicated when we consider also daylight that has different spectra and all the reflection, because this MELED is very difficult. So I skip for some slides because this is a very complicated effect. One important thing is that if, for example, we are in an environment without daylight, let's start with a simple case. Obviously, we have to consider horizontal illuminance for the task area, but also vertical illuminance, because as you have seen, vertical illuminance is proportional to MELED, considering MELDER. So we have these two requirements, vertical illuminance and horizontal illuminance. So in this case, it's really important to select the luminaires in order to obtain a good ratio of vertical to horizontal illuminance, of course, taking into account for the spectral power distribution of the sources and also for the color of surfaces of the environment, because we can change things by modifying these aspects. And now, just because the time is very running, I don't want to show in detail all the different cases, but as you can understand, we can change parameters. For example, I noticed that if we use a direct indirect pattern, we obtain a good ratio between horizontal and vertical illuminance, and so we can achieve requirements both for horizontal, for visual and non-visual effects. We have also to consider that in these cases, we have also to think that these requirements for non-visual effects are important during the morning, not during the afternoon. So it is possible to change things during time, and also to change, for example, through, for example, wide tuning systems, to change the spectral distribution of light and specifically the correlated color temperature, in order to obtain variable lighting according to daylight variation, for example. So this could be the future of lighting, I believe. And the things are more complicated when we have also daylight and electric light together, because daylight could achieve these requirements, but electric light not always. So the integration of two should allow us to obtain good conditions. And how to obtain these conditions? This is the difficult thing. Obviously, we can calibrate the control systems because control system can balance electric light in order to integrate daylight. But to calibrate them, we have to consider if we want to achieve illuminance on the tables, or we want to achieve the proper vertical illuminance for melee. And so results are really interesting, but not really clear. So something should be done for this. So as you can see, we have also this aspect for non-visual effects, which is really, really important and requires the use of automatic controls. And the last, we have the energy performance of lighting. And the energy performance of lighting is achieved through, is obtained through, as I told you, the light energy numeric indicator. It is the total energy that is required for lighting, divided the area of the building, of the illuminated area of the building, and in its turn, it is the sum of the energy required for lighting and also the energy required for the standby and battery recharge. But if we concentrate us toward the energy for lighting, here is the method. This is the energy for standby, and this is the energy for illumination. Obviously, the energy is the product of power by time, but we can reduce the time of switching on the luminaires, but we can also reduce the energy through these factors, and specifically the light dependency factor and the occupancy dependency factor. This is, I don't want to deep into the constant illuminance factor, but with these two factors, FD and FO, it is possible to save a lot of energy. How? I can show you very briefly that the energy is the product of power, P, by time. Time Td is time where daylight is available. Tn is the time where daylight is not available. And we can use the factors Fd and Fo to reduce this energy. How? Considering daylight availability, so more daylight is available, the better, and to use automatic control systems. But automatic control system, as you can see, we have several types of automatic control systems, and by considering these aspects together, we can save a lot of energy. Let's consider that automatic control systems in their turn are very difficult because the sensors that in general are not considered are very different for their sensitivity, both spatial and both spectral. So nothing is said on the standard about this, but results can vary a lot considering different sensors. So concluding with lighting quality, we have to observe that we have several. The future is on control system, in my opinion, and to achieve all both non-visual and visual effects and also save energy, we can use control systems, but we have at our disposal different control techniques. For example, simple switching on-off, step switching or dimming. Considering different systems, for example, based on only daylight detection or both daylight and electric light detection, and also calibration has its own importance. And obviously, in this case, we should consider all together, and in some cases, in every case, to have a project, a design that considers, that balance all these aspects. So I want to conclude saying that it's not easy to design lighting systems, considering together all the aspects. Second, we have a lot of standards and guidelines. So the problem is that sometimes they are not in perfect agreement, and they provide essential benchmark, but they gave framework rather than rigid prescriptions. So it is the designer role to synthesize all these requirements to find a sustainable solution, good solutions. It's really, really difficult. And we have a lot of software tools, but they have different characteristics. So their choice and use require awareness and also expertise. And finally, I wanted to promote automatic control system because they play a crucial role for balancing all these aspects together. I would also finish saying that I would like that research and practical design should be more should be closer, because otherwise we perform a lot of research, which is very, very complicated. And on the other side, these aspects are not practical to be applied. So we have to work all together to consider all these things in a better way, perhaps working on software and also working on standards in order to uniform and harmonize the different standards. And with this, I say you teşekkür ederim, and thank you so much.
Thank you so much. Biz de size teşekkür ederiz. So it was very nice to listen from you from different aspects, actually unifying all them, just like you mentioned in your topic. And also, we should be in contact with each other by means of working at an interdisciplinary area. I'm fully agree with you to work together. Scientific solutions, that automatic control systems, the lighting sector all together making projects, and also at an interdisciplinary area, just like under the umbrella of CIA.
Yeah.
So, which is very valuable and functional, I think. So I kindly ask all the participants if they have any contributions and or questions to share or to ask to you. Any few words, remarks. I have been checking in the chat box. We don't have any message there.
They remained astonished.
Actually, I was wondering your views about the future of lighting, including all the standards. You mentioned a few on them. Maybe you can say a few more words
Yes,
about it,
yes.
considering all the standards and all the things done in the field.
Yes. For example, I noticed that the standards dealing with daylight are different from the standard of electric light. So sometimes it is difficult to apply both together. For example, let's say the calculation surfaces, their height, the calculation grids are different. So if I use daylight and electric light together, how can I manage this? This is due to the fact that generally people working in the light doesn't work in electric light. They don't speak each other. So I think it's our duty to put together these working groups and say, okay, let's harmonize the standard. Second, we have to consider dynamic light as something that should be received, not only static light. So in my opinion, it seems that even the 464 for indoor lighting is the ancient standard that was modified, but doesn't take into account for the actual technologies that today we can have. So even the choice of correlated color temperature can be varied during the day, for example. And we have to show in the project the ideas. These are not reported in the standard.
So we collect data from different standards for the well and health, for example, embedding it to that door lighting standards.
And also for energy issues, it seems that LENI is apart. So we do something and then, we have to apply the LENI. But there's no match among them. So it's really important a last important thing for all the plants and facilities in a building, we are moving toward digitalization and the BIM, building information modeling. So this should be done also for lighting. So the fact that we have several software, and sometimes I speak as a researcher or teacher, I noticed that this software are changing. Sometimes we model, let's say, with one software, and then this software is changing. We prefer another model, and then we put the results to another processor just to obtain some results. We don't have something that is comprehensive of all the aspects. So this is difficult for researchers, but I think it is impossible for designers. And so I asked to some lighting designer in Italy, for example, and they aren't aware at all of integrative lighting. This is a pity, in my opinion. We have to work on this just to make things easier to be applied. Otherwise, they will not be applied.
Okay, thank you. I think Sarmin Hocam has a
Yes.
question or contribution, and then I see Vicenta Sukopakaza. Yes, Sarmin Hocam.
Yeah, thank you very much, Laura. It was very comprehensive, but it should be explained this way, because otherwise, if you say it in a simple way, it's not certain for the application. But about the CIA, I think also we are working together. But this subject is basically it's close, of course, for the Division 3. And
Yes.
you have mentioned that it's also it needs a little bit clearly explanation. What is the correspond to each other? What is the effectiveness of each other? What is the aim of this calculation? And to give this sum, it's a guide, a practical guide to the implementers. Of course, it's very important. And you mentioned that about the Jennifer had a
Yeah.
technical role, but maybe it could be research for the discussion. And after that, maybe how I would like to ask about the Division 3 strategy of this. And also one more thing is about the integrated for the building systems. And
Yes.
also we have to take care of the heating, ventilation, air conditioning
Yes.
systems together. It's very important for the energy efficiency and it's effective. Please say a few words, and because there is another question now. Thank you very much for all the contribution. Thank you.
To
Okay.
you, Jeremy.
We have maybe Vicenta Skopakas can say it from Brazil. Melanopic EDI is for people active during the day. How about night shift workers?
Oh, yes. For night shift workers, we have known the solution by now, because obviously, if we have people who perform some work with different pattern, for example, let's say who is selling fruit, for example, in Italy, they awake very early in the morning and then they go to sleep very early, but the day is always the same for them. The problem is with shift workers, because they change continuously their pattern. So some research is performed, but unfortunately, it is their activity that is not good, not the light. So it's difficult. For example, if I have to work during night, for example, I have to drive something, it's necessary that I am awake, otherwise I risk to have an accident. So I cannot, it is impossible to balance these two things. In generally, we as human beings, as for all the other animals in the world, we are accustomed to the night-day pattern, so dark and light. So if we change this, this is a problem that should be considered, but we don't have a specific solution, even because these people is changing or they do night shifts randomly sometimes or without a general pattern. So this is the real problem. So now we are working for lighting for people who is working during the day and sleeping during the night. But I know that this is a real problem. And this problem should be solved also considering the specific activity of people. So, for example, if I have to stay not perfectly awake, I could receive something. But if I have to stay awake, it's different. Otherwise, and I noticed another thing, for example, that using, let's say, warm light, so reddish light during the night, just not to melatonin strongly. I noticed that they noticed, some researchers, that the pupil size was increasing because generally it is blue light that produce the variation in the pupil size. So some people had the problems for reading or doing something. So I think that it is very, very difficult to obtain a good pattern of light for shift workers. But this is a topic of research.
Okay, thank you. And maybe again going back to referring to Sarmin Hocam's contribution, maybe finally you can say a few words regarding the strategy of Division 3 and the strategy of Division 6, maybe
Yeah.
combining all of
They-
these working areas, how to unifying them.
So, in my opinion, one important thing in Division 3 is that we have, it is true, it is correct, two subdivisions, electric light and daylight. So we have also two associate directors for this. So it is important that these two directors should speak each other and do something together rather than separate things. This is really, really important. And as for Division 6, it is also important, but Division 6 should provide us, to provide to Division 3, what are the rules to be followed. So today I told you that during the morning we have to achieve at least 250 lux, melanopic, MELEDI lux. But it is a proposal from scientific research. Of course, we have to keep in touch with the results from research to vary this pattern and to write proper standards. This is really important. So Division 6 is more devoted to understand what are the effects, and in Division 3 should work on how design lighting systems to achieve the results or the requirements provided by Division 6. These are the rules of 2.
Okay, thank you. Peter has a message, Peter de Hoff. He says his regards from Austria and thank you for the presentation. It was so lovely to see you again, and also it's too lovely to get this message from you, Peter. Thank you for being with us.
Thank you,
Jose
Peter.
Luis Pimenta asks, is the correlated color temperature value still a good indicator for the integrated lighting analysis?
No, not at all. In this very brief presentation, it wasn't, there was no time to explain this. Obviously, we have to speak about the spectrum. And as I noticed, we have different also software. Those software that are based only on photometric quantities use correlated color temperature, but the real thing is to use the spectrum. Also because, for example, for LED lamps, we have the peak in the blue region, but this peak could shift according to the different technology. And so we have, for example, the same correlated color temperature, but very different melanopic effect. So in general, both for visual and non-visual effects, I say, correlated color temperature is only something which is aesthetic for me, but the real calculation should be done considering spectral characteristics.
Thank you. And we have a message from Sabri Günaydın, as usual, and as always, he's with us again. So he says, thank you for the presentation. And he also says, excellent presentation for you. Özge Sener, thanks again from the insightful presentation. And she says she appreciates the opportunity to attend this valuable webinar organized by us. And regards from Gebze Technical and regards to you from Istanbul, Özge. And if you don't have any other messages or contributions, I think we can end this webinar now.
I
Yes,
would add
please.
only one thing. I am aware that I put a lot of things in this presentation, and I'm aware also that something is not so clear, but I am at your disposal to answer all subsequent questions or clarify something that I think is said in a quick manner. So please, it's not necessary that now you ask me something, but you can contact me and I'll answer or give you material if you want to deep some of these aspects.
No, thank you very much, Laura. It was really a nice idea for the young researcher. Yes, because it's a very popular subject now for the lighting area, human-centered lighting, and you have already mentioned all of the how can we say approach yes of this. Thank you. Maybe Banu Hocam, before the leave, please ask to some participants to open the camera to take a
Take
photo
a photo, of
for
course.
this. Yes,
Of
yes,
course.
yes, with Laura. And we will be together next October.
And
And yes, for the
lastly,
workshop.
Lastly, let me read Elif Raner's message. Dear Laura, thank you so much for
Oh,
your
hello, Peter.
presentation. She
Thank you.
said, Peter,
Thank
hi.
you. Thank you.
Thank you, thank
Thank
you,
you.
thank you. And I think Nimet will take some photos. Yes.
Yes, of
You
course.
are all ready. I think we can take the photo. So we kindly ask everyone to open the cameras just for 1 second to take a photo for the remark of today as a memory. For lights.
For lights. Day of light.
Day of light.
It's okay.
Light which unifies us.
Okay, there are many participants from the abroad. It was very nice. It's an international event.
Yes,
Yes,
thank you.
it's really, thank you very much for Laura and also for the organizing Banu and the other, of course, member of the National Committee. We will continue. Yes.
And also, Hocam, lastly, as now we're at an international platform, let me announce one important thing for Turkish National Committee on Illumination. Lux Europa will be organized in Turkey by Turkish National Committee in 2028. So please
And
follow
maybe
us.
you can read much more message from the Brazil College, please. Sarah,
So,
wonderful to see you again. It's also wonderful for me. Yes,
so,
thank you. We keep
so
ourselves.
we will be glad to be with you on both of these platforms, online and also face to face, and we will be very valuable to welcome you in Istanbul, in Turkey. So please follow us from all the social media platforms.
Thank you. Thank you to all of you.
Have a nice week.
Bye. Thank you.
Laura, maybe you can a little bit, yes.
Yes.
Wait. Our national committee members and also our Elif and Nargis is here. Yes, Feride. Nimet, can you do anything? Can you make some help to leave some participants? It is possible. Mhm.
Wow.
Mhm. Okay, thank you very much, Laura, and Feride, and Elif, and Nergis, and also where is the oh, yes. Would you like to say something to Laura? Mhm.
Dear Laura, thank you. See you soon as
Thank
as
you,
possible.
Elif.
Bye.
I think
Thank you.
everything is okay. Yes.
Bye.
Thank you, National Committee.
Thank you
Yes,
very
yes.
much for
You are also a
presentation,
member of
Laura.
National Committee, Elif. Yes, it's going to, yes. Thank you very much. Thank you. Okay, see you later. I think so. Yes, it was a rarely, and you are a little bit hesitated about because we were very busy during the weekend, but I think it's already very nice organization, and you gave us very valuable information, knowledge. It's yeah, that's to remark of the what is the importance of this approach. That's very really nice. Thank you very much.
I thank you, Sermin. I thank you
Thank
so
you.
much for this.
Thank you. Thank you.
And thank you all the committee, because I know Banu and also Feride and all of you, Nergis, you are wonderful. You are working.
We are family, Laura.
Yes.
We call it is the ATMK family, and also we have accepted you to our family. Thank you very much.
You're welcome. Thank you to you.
Have a
very much.
wonderful week.
Thank you. Thank
Have a
you.
wonderful
Bye-bye.
Thank you so
Bye-bye.
much.